In this lecture, we are going to discuss solve examples of Cramer's rule. Example number 1. Solve the equations using Cramer's rule. X plus 2y is equal to 7, comma 2x minus y is equal to 4. Solution. In this question, we are given two equations of first degree, or we can say two equations of straight lines. The first equation is x plus 2y is equal to 7, and second equation is 2x minus y is equal to 4. The first step, according to the Cramer's rule, first step is we have to list the coefficient of x, coefficient of y, and constant. The coefficient of x is 1, the coefficient of y is 2, the constant is 7. In the second equation, coefficient of x is 2, coefficient of y is minus 1, and constant term is 4. So the first step, according to Cramer's rule, is listing the coefficient of x, coefficient of y, and constant. Now the second step, after listing the coefficient of x, coefficient of y, and constant, now the second step is we have to find the value of d, d1, and d2. D means determinant of coefficient of x and coefficient of y. D1 means determinant of constant and coefficient of y. And d2 means determinant of coefficient of x and constant. So let's find the value of d at first. To find the value of d, that means d is the determinant of coefficient of x and coefficient of y. So coefficient of x is 1, 2, and coefficient of y is 2 minus 1. So we have to find the determinant of coefficient of x and coefficient of y. Now according to the rule of determinant, the difference between the cross product, is the determinant of, let's multiply 1 into minus 1. If we cross multiply, then we get 1 into minus 1. Then we have to take the difference, minus 2 into 2. So 1 into minus 1, we get minus 1. 2 into 2, we get 4. So minus 1 minus 4. That means minus 1 minus 4, we get minus 5. Now next we find d1, determinant of constant and coefficient of y. So to find d1, we have to delete, or we have to cancel coefficient of x. And coefficient of x, we have to replace by the constant term. So first we take constant term, then we take coefficient of y. The coefficient of x, or we can say the first place, the first column is replaced by the constant term. So d1 is the determinant of constant and coefficient of y. Now let's find the value of d1. So formula of determinant is AD minus BC. That means if we suppose the elements of first column as AB and the elements of second column as CD, then AD minus BC gives the value of determinant. So 7 into minus 1 minus 4 into 2. So taking the cross product and then difference, we get 7 into minus 1 minus 7, 4 into 2 8, minus 7 minus 8, we get minus 15. Now d2 is the determinant of coefficient of x and constant. To find d2, we have to replace coefficient of y by constant, or we can say to find d2 we have to cancel the second column. To find d1 we have to cancel the first column, and then we have to replace the column which is cancelled, we have to replace by the constant. So in case of finding d2, the value of d2, we have to cancel the second column d2, that means cancel the second column, and the column which is cancelled we have to replace by the constant. So d2 is the determinant of 1 2, then we have to cancel the coefficient of y, and the coefficient of y we have to replace by 7 4. So d2 is the determinant of x, coefficient of x, and constant. Now let's take the cross product of the diagonals and take the difference. So 1 into 4 minus 2 into 7. That means 1 into 4 we get 4, minus 7 into 2 we get 14. 4 minus 14 we get minus 10. The value of d, we have got minus 5. Value of d1 we have got minus 15. And the value of d2 we have got minus 10. Now we'll apply the formula of Cramer's rule. According to Cramer's rule, the value of x is obtained by d1 by d. The value of x we find out by d1 by d. and the value of y is obtained by d2 dividing by d. So formula of x is d1 by d and formula of y is d2 by d. Now d1, the value of d1 we have got minus 15, the value of d we have got minus 5. So minus 15 divided by minus 5 we get 3. Now d2, the value of d2 we have got minus 10 and the value of d we have got minus 5. So minus 10 divided by minus 5 we get 2. Therefore x, the value of x is 3 and the value of y is 2. Therefore x comma y is equal to 3 comma 2. This is the required solution of the given two equations. Now checking, the first equation is given x plus 2y is equal to 7. The first equation is given x plus 2y is equal to 7 and the second equation is given to x minus y is equal to 4. So we can verify our answer by substituting the value of x and y in the first equation and again by substituting the value of x and y in the second equation. If the value of x and y satisfies first equation and the second equation, then the value of x and y is correct. That means our solution is correct. So first equation is x plus 2y is equal to 7. The first equation is x plus 2y is equal to 7. The value of x is 3. So putting the value of x 3 plus 2 into y. The value of y is 2. Now 2 to the 4. 4 plus 3. We get 7. So 7 equals to 7. Hence it is verified. We can check by the second equation also. By taking the second equation also. You put the value of x and y. Then the value of x and y satisfies the second equation also. The value of x is 3 and the value of y is 2. So 3 to the 6, 6 minus 2 is equal to 4. That means the value of x and y satisfies the second equation also. So we can check whether our solution is correct or not by putting the value of x and y in the first equation and in the second equation. The value of x and y, that means 3 comma 2 satisfies both the first and second equation. Hence 3 comma 2 is the required equation. Example 2. Solve the following equations using Cramer's rule. Solve the following equations using Cramer's rule. So in example 2, we have to solve 3 equations. 2x plus 3y is equal to 4, 4x minus z is equal to 5, 4y plus 3z is equal to minus 5. We have to solve the equations by using Cramer's rule. Solution. The first equation is 2x plus 3y is equal to 4. So we are given 1, 2, 3 equations in variables x, y and z. In the first equation, the variable z is missing. So we can arrange the terms. 2x plus 3y, the variable z is missing. So we can write 0 into z is equal to 4. So first step is arranging the terms by writing the missing variables. Now second equation is 4x minus z is equal to 5. So in the second equation, the variable y is missing. So we can write 4x as it is. The variable y is missing. So we can write plus 0 into y minus 1 into z is equal to 5. So this is the second equation. Arranging the second equation in terms of variable x, y and z. Now in the third equation, the variable x is missing. So we can write 0 into x plus 4 into y plus 3 into z is equal to minus 5. So first step is arranging the first and second equation in terms of the variables x, y and z. So now we have got 3 equations. Now the first step of Cramer's rule. The first step of Cramer's rule is listing the coefficient of x, coefficient of y, coefficient of z and constant. Because in the given equations we have variable x, variable y, variable z and constant. So first step of Cramer's rule is listing the coefficient of x, coefficient of y, coefficient of z and constant. Now the second step of Cramer's rule. The second step of Cramer's rule is finding the value of d, d1, d2 and d3. That means we'll find the determinant by taking coefficient of x, y and z. Expanding by taking the first row. In the first row we have the elements 2, 3, 0, 2, 3, 0. Now when we expand by taking the first row, we take the first element. So when we take first element, we have to delete the corresponding row and corresponding column. That means we have to delete 2, 3, 0 and 2, 4, 0. So when we delete the corresponding row of 2 and corresponding column of 2, that means first row and first column, then 0, 4, minus 1, 3. Then 0, 4, minus 1, 3 are left. So we have to find the determinant. Again, expanding by taking the element 3, plus, minus. The sign of 3 we have to take minus. So when you expand by taking element 3, then the row of 3 and column of 3 we have to cancel. So when you cancel row of 3 and column of 3, then 4, 0, minus 1, 3 are left. 4, 0, minus 1, 3 are left. Then we have to find the determinant. Plus, now we have expanded by taking first element 2, we expanded by taking second element 3, now we have to expand by taking the third element 0. So when we expand, we follow the same process. We have to delete the row of the corresponding row and corresponding column. That means we have to delete row of 0 and column of 0. Then if we cancel the row of 0 and the column of 0, then if we cancel the row of 0 and column of 0, then 4 0 0 4 are left. 4 0 0 4 are left. Now to as it is. Now to find the determinant of 0 4 and minus 1 3. To find the determinant of 0 4 minus 1 3, we have to cross multiply and take the difference. 0 into 3, we get 0, and then minus 4 into minus 1. So minus minus will be plus. So we get 4 into 1, 4. That means 0 into 3, 0, then minus minus will be plus. 4 into minus 1, we get plus 4. Now similarly, expanding, finding the value of the determinant 4 0 minus 1 3, we have to multiply, cross multiply and take the difference. So 4 3s are 12. Now minus 0 into minus 1, minus 0, minus plus 0. So we get 12 plus 0 plus 0 into something, we get 0. So 2, 4 plus 0, 4, 4 2s are 8, 12 plus 0, 12, 12 3s are 36. That means minus 36. Now 8 minus 36, we get minus 28. So this is the value of D. The value of D is the determinant of coefficient of x, coefficient of y, and coefficient of z. To find the value of D1, we take constant, coefficient of y, and coefficient of z. To find the value of D1, we remove coefficient of x, and the coefficient of x is replaced by constant. The coefficient of x is replaced by constant while finding the value of D1. So first we take constant, that means 4 5 minus 5. We take 4 5 minus 5. Then we take 3 0 4. Then we take 0 minus 1 3. That means while finding value of D1, we have to cancel coefficient of x, and the coefficient of x we have to replace by constant. So we take constant, then coefficient of y and coefficient of z. So to find value of D1, we have taken constant, coefficient of y and coefficient of z. Constant, coefficient of y and coefficient of z. Constant, coefficient of y and coefficient of z. Now to find the value of this determinant, we are going to expand by taking the first row. In the first row, the elements are 4 3 0. 4 3 0. According to the sign rule, the sign of first element is plus, the sign of second element is minus, and the sign of third element is plus. Plus, minus, plus. So let's take the first element 4. So when we expand by taking any element, then we have to delete the corresponding row and corresponding column. So we have taken the first element 4. The row of the element 4 is first row, and the column of the first element 4 is first column. So deleting the first row and first column. Then the elements are 0 4 minus 1 3. 0 4 minus 1 3. Again expanding by taking the second element minus, we have to take the sign minus for the second element. Now we have to delete the row of the second element and the column of second element. That means we cancel the row of 3 and column of 3. Then the remaining elements are 5 minus 5 minus 1 3. 5 minus 5 minus 1 3. Now next expanding by taking the element 0. So when we expand by taking the element 0, then we have to cancel the corresponding row and corresponding column. Then the elements are 5 minus 5 0 4. 5 minus 5 0 4. Now we are going to find the value of first, second, and third determinants. Now 0 into 3 0 plus minus minus plus 4 into 1 4. So while finding determinant, we have to take the difference between the cross product. 0 into 3 0, then minus, but again we have got minus. When we multiply 4 and minus 1, we'll get minus. So minus minus plus 4 ones are 4. Now again finding the value of the second determinant. 5 into 3 15, then minus, then minus minus plus, plus minus, again minus. So 5 ones are 5. Now 0 into something, we get 0. So 4 plus 0 4. 4 4s are 16. 15 minus 5 10. 10 3s are 30. So 16 minus 30, we get minus 14. This is the value of D1. To find the value of D2, we take coefficient of x, constant, and z. To find the value of D2, we cancel coefficient of y, and the coefficient of y we replace by constant. That means to find the value of D2, we take coefficient of x, then we take constant, and then we take coefficient of z. D2 is the determinant of coefficient of x, constant, and z. Now to find the value of D2, let us expand to find the value of this determinant. Let's expand by taking the first row. In the first row, the elements are 2, 4, 0. The elements are 2, 4, 0. The sign will be plus, minus, plus, plus, minus, plus. So when we expand by taking the first element 2, we have to delete the corresponding row and corresponding column. That means we'll delete first row and first column. So when first row and first column are deleted, then 5 minus 5 minus 1, 3. 5 minus 5 minus 1, 3 are left. Now we take the second element. The sign of second element is minus 4. Then we delete row of the second element and the column of the second element. That means we'll delete the row of 4 and column of 4. Then 4, 0 minus 1, 3. 4, 0 minus 1, 3 are left. Then next we expand by taking the third element. Then to expand by taking third element, we delete the corresponding row of 0 and the corresponding column of 0. Then 4, 0, 5 minus 5. 4, 0, 5 minus 5 are left. Now let's find the value of the first determinant, second determinant and third determinant. 2 is as it is. 5 3s are 15. We have to cross multiply and take the difference. 5 3s are 15. Then minus, 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 plus, plus, minus, minus. That means again we get minus sign, and 5 1s are 5. Minus 4 as it is. Now let's cross multiply and take the difference. 4 3s are 12. Then minus, 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 plus, 0 into 1, 0. 0 into something we get 0. 15 minus 5, 10. 10 2s are 20. 12 plus 0, 12. 12 4s are 48. So 20 minus 48, we get minus 28. So minus 20 is the value of D2. Now next we find the value of D3. To find the value of D3, we have to cancel coefficient of Z, and coefficient of Z we have to replace by the constant. That means to find the value of D3, we take coefficient of X, coefficient of Y, and then we take constant, because coefficient of Z is replaced by constant. That means coefficient of X, coefficient of Y, and constant. We have taken coefficient of X, coefficient of Y, and constant. Coefficient of X, Y, and constant. Then we get value of D3. Now, to get the value of this determinant, we choose first row and expand it. The elements of first row are 2, 3, 4. 2, 3, 4. And the sign we have to take plus, minus, plus, according to the sign rule. Now, by taking the first element 2, let's expand by taking the first element 2. So, according to the rule, we have to delete corresponding row and corresponding column. Then 0, 4, 5 minus 5. 0, 4, 5 minus 5 are left. Now, second element is 3. The sign we have to take minus, because plus, minus, plus. The sign of second element we have to take minus, so minus 3. Now, to find the according to the expansion rule, we have to delete the corresponding row of 3 and column of 3. Then 4, 0, 5 minus 5. 4, 0, 5 minus 5 are left. Now expanding by taking the third element. The sign is plus. Now when we expand by taking by the element 4, we have delete corresponding row and corresponding column. Then 4, 0, 0, 4. 4, 0, 0, 4 are left. Now let's find the value of first, second, and third determinants. So 2 as it is, we have to take the difference between the cross product. 0 into 5, 0. Then minus, we have to take the difference. So minus 4 5s are 20. Minus 3 as it is, we have to take the difference between the cross product. So 4 into minus 5, minus 20, and then minus 0 into 5, we get 0. Plus 4 as it is, 4 into 4, 16, then minus 0 into 0, 0. Now minus 20 into 2, we get minus 40. Minus minus plus 20 into 3, we get plus 60. Then 16 minus 0, 16. 16 4s are 64. 64. Then 60 minus 40, we get 20, plus 64 as it is. 64 plus 20, we get 84. So 84 is the value of D3. So we have found the value of D1, D2, D3, and the value of D. Now according to the Cramer's rule, the value of X is equal to D1 by D, the value of Y is equal to D2 by D, and the value of Z is equal to D3 by D. So this is the formula of Cramer's rule. The value of X is D1 by D, the value of Y is obtained by D2 by D, and the value of Z is D3 by D. Value of D1 we have got minus 14. And the value of D we have got minus 28. So 14 by 28 we get 1 by 2. 14 1s are 14, 14 2s are 28. The value of D2 we have got minus 28. The value of D is minus 28. 28 28 cancel, we get 1. And the value of Z is D3 by D. The value of D3 is 84. And the value of D is minus 28. Minus 28 plus minus minus 28 is 84. So we get value of, we have got value of X 1 by 2, Y value 1, and Z value minus 3. Therefore X comma Y comma Z is equal to 1 by 2 comma 1 comma minus 3. So this is the required solution. We can check our answer, or we can verify our answer by substituting the value of X, Y, Z in the first equation, second equation, and the third equation. The first equation is 2x plus 3y is equal to 4. We have taken the first equation, 2x plus 3y is equal to 4. 2 as it is, the value of X is 1 by 2, plus 3 as it is, the value of Y is 1. So 2 cancel, we get 1. 3 1s are 3, so 3 plus 1, 4. So 4 is equal to 4. That means the values of X and Y satisfy the first equation. Similarly, we can put the value of X, Y, Z. We can put the value of X, Y, Z in the second and third equation, and we can verify the solution. Hence, we can say that 1 by 2, comma 1, comma minus 3 is the required solution of the given equations by the Cramer rule. Thank you. Thank you for watching.